The next section will be a little more about truck scales, motor truck scales. We want to talk a little bit about installation. We want to talk a little bit about some jacking and cribbing. One of the things that we'd like to ensure is that when you are jacking up a scale, this is, for example, the weighbridge steel in a scale, and let's say this is a section, this is a section, here's a section, and here's a section. There's a lot of different ways to do things, and it may be your philosophy to jack up, to build a cribbing right here and jack up and work on these two sections at the one time. As long as you're doing things safely, I'm not going to say there's anything wrong with this. I think in talking to managers of scale companies over years, I think it's sort of inferred that it might be a little bit safer to work on one section at a time. I think people have less safety events or less incidences. We want to be sure that when we're building our cribbing, there's really just a couple rules to follow. Good square, rectangular, hardwood, whatever you have. And then as we build that cribbing, the next level of our cribbing is going to be slightly inside as we go up. There's going to be scenarios where obviously there's an example of a terribly non-level cribbing. We might use small pieces of wood to make sure that our cribbing is level. Depending upon how high we go, I've seen instances where we have to jack the scale up a long way. Let's say we were doing some weighbridge steel repair, or it's possible that we might even be sandblasting, painting, priming the weighbridge. So if you've got to go a long way, one of the things that probably needs to happen is you don't want to get too greedy. I mean, you need to take it up, say 8 inches to 10 inches here, and then work your way down the scale and back on the scale. And when you get in those really, really tall cribbings, one of the things that I've done in the past are taken 2x kickers and have them go all the way across the scale, toenailing them into the cribbings on both sides. That makes a nice, secure, that really braces up your cribbing, doesn't allow it to move. In many cases, someone would build their cribbing and use a jack right here. Jack and cribbing. There are a couple of things that would be pretty common. For safety's sake, they might use a 3-legged jack stand. Jack stand. In conjunction with their jack, we don't want to depend just on the jack. It seems as that's when something will leak down, somebody else's finger will get in trouble. One of the things that we always want to be sure of is this is again weighbridge steel, and your jack stand is also steel. So we want some sort of wood, whether it's a plywood, 1x, or whatever you can get in there. But you always want to put some wood between the two pieces of steel. If you're not using this jack stand, then one of the favorite things to do might be, once you jack this up, to take a piece of wood and go all the way out towards the end of the weighbridge steel, standing up an appropriately lengthed piece of wood or shimming this, and this would just simply be a safety block. Safety block. And obviously do that on both sides of the scale. I mean, whatever you do, you're going to do on both sides of the scale. Urge you to, make sure that you're abiding by safety rules whenever anybody knocking parts out of a scale, knocking parts into a scale. Make sure that everybody's wearing safety glasses, not just the guy that's knocking the parts in or out. Everybody in that immediate area is wearing the proper safety glasses, side shields, whatever. When you are beating two tools together or beating pivots and bearings in or out of a scale. Another thing, there are a couple of other things we'd like to cover just for general knowledge. And again, my experiences here are more with a Rice Lake scale. We have new technicians, and let's say this was a full electronic scale. One of the things we might like you to know is that these end load cells, if for whatever reason you need to check them, they would each be probably something like about 0.7 millivolts, while anything out here in the middle would probably be about double that, 1.3 or 1.4 millivolts. This would be just the amount of dead load in terms of millivolts in a standard Rice Lake scale, just in case that ever helps you. We'll go away from that now and talk a little bit about grouting. One of the things about grouting that you want to be absolutely careful of is your personal protective equipment. I've seen a lot of grouting done without glasses, without side shields, without masks, without any gloves or barriers for hands. And that grouting, after you do a little bit of that now, that will dry you up pretty good. So we want to be sure everybody's using their personal protective equipment. In any sort of grouting of a fulcrum stand, there's always a scenario where, say, this is the pier and this is whatever the fulcrum stand consists of. One of the things that we want to be absolutely sure of is, if you have less than 1/2 of an inch here, you better be really, really careful. It is no matter how wet or watery your grout is, it is very hard to get grout in this material, in this area right here, between the fulcrum stand and the pier. If you don't have at least a 1/2 inch, and I mean if you have a 1/4 inch, it is virtually impossible. I don't care how wet it is, it just doesn't really flow in there like it should. So a lot of scenarios happen these days where because we have the ability to simply shim sections in a full electronic truck scale, in many cases the fulcrum stands are set down on the piers and then shims are used. But I'm sort of old school. If it needs to be grouted because the pier is not as sitting exactly as it should, that's kind of an important deal. All right, so we've talked about grouting and jacks and cribbing and bracing, jack stands, safety blocks. There's a couple things about working on a scale that I really suggest you be aware of, and one of them is that if you're doing anything in a scale, and you need to be able to see well, you need good lighting, and that obviously in scenarios where we might have some water in a pit, we want to be very, very careful of extension cords and lighting. But if I'm doing some work in a scale, I'm going to want 3, 4 clip-on lights, a few extra bulbs, so that I've got good lighting, so that you can really see what you're doing. We'll talk a little bit about jack up and grease jobs, but on the initial installation, one of the things that I almost always wanted to happen was, once the lever system was installed, then the weighbridge and the cross members would be added to that, and then the bracing for the deck coping would be done. And at that point right there, when we're about to cover up, maybe before you put the tin across the weighbridge for the bottom of the deck, at that point in time, I'm really going to suggest go back and look at the alignment, whether if it's a mechanical scale of all of the links, make sure the pivots and bearings are seated properly, make sure you don't have a pivot and bearing that's out, because even though it was in at one point in time, bouncing that weighbridge, those big beams, it's easy to knock something out. So we want to be kind of careful at that point in time. Again, when you do have a pit full of water, you know, we talked about levers floating. Obviously, levers are not going to float, yet they do have a certain amount of buoyancy. So, you know, when a pit is full of water, the range behind zero for many indicators is really, can be very, very narrow. So it's not uncommon that a scale will blank out or go behind zero when the pit's full of water. So when someone calls you and says, hey, my scale is behind zero, all it says is minus or under, you know, a lot of our indicators do under dashes. Okay, well, you know, open up, maybe take the top off the manhole and take a look in, and does it look like, you know, the pit is full of water? Now that brings up a couple of other things. You know, again, water and electricity don't mix very well. So when we are putting a pump down into a hole, or, you know, if the pit is full of water, in many cases, you know, I would suggest a totally sealed pump, you know, the right type of pump with maybe a 20-foot discharge hose. You know, if it's got a 10 or 12-foot electrical cord on it where we don't have to make a connection down in the pit, that's nice. It's nice if it has its own trigger or its own actuator, so that, you know, all we've got to do is let that pump down into the pit itself, and it'll simply start pumping and carrying water away from the scale. It can take a long time to pump out the water in a 60-foot scale. But again, the biggest thing to do there is make sure that's being done safely, because again, making that electrical connection from an extension cord to a pump in the bottom in the pit, and or if your pump is not a sealed unit, it can be very, very dangerous. There's a lot of just sump pumps for house out there that I've seen used in scale pits, and that can be very, very dangerous if you're not using the right kind of pump. In certain scenarios over the years, I've seen in pits where the walls will actually begin, let's say, I'll change this around a little bit. We're looking at an end view on the scale, and let's say we have our deck here, and the deck is on some weighbridge steel, and what happens is these side walls, it's probably a 6-inch wall on both sides of the scale. I don't know how much I'm drawing it to scale. They can actually, because of poor soil conditions, they can begin to move in a little bit. And want you to be aware that if the need arises, you can take a wood or a block and take a hydraulic jack and put the pump down, and you can jack these walls out. My advice after that would probably be get some adjustable basement supports, and because even, you know, if you just jack it out, you're then going to need to support it. I've seen a couple different scenarios here between here and here under the weighbridge, and I've seen where people have cut out holes in the weighbridge, and you want to keep those to sort of as small as possible, and you definitely want to have clearance. You can do that one of two ways, but yeah, if the wall begins to move in on a scale, another thing to be aware of is this little, as a part of the deck coping, there in many cases is a rock crusher, so that C-R-U-S-H-E-R, and it could be round and it could be square, but in certain scenarios, if it just gets a little bit tight here, you may just grind a little bit of the rock crusher off, or you might take a torch and cut some of it off. You could do either one of those things, but it's not a big deal. Now, if you've got a 60-foot scale and the walls are moving in on it, you're probably going to need 3 or 4 braces from center going each way to keep those walls held out. But I've done that a couple of times, and it's not a terribly rough job. On the initial install of a system, we've talked about the scale being lever and levers being level. One of the things that I think is kind of a newer fad, so to speak, because so many scales are above ground, just taking a proper height or diameter of round thick wall pipe and putting under the weighbridge steel until everything is located or centered up between the approaches is now becoming a pretty popular thing to do. That pipe allows you to put all of your sections together and have them fit or float freely, and you can still move it around just very, very easily with a little crowbar on the end. And then once you get the scale centered up between the approaches, you might take some wedges, between the scale and the actual approach. Might take some wood wedges and just push that in there so that the scale doesn't move around anymore. Because again, it's going to roll around pretty freely, but you take a couple of wedges in each end, and that's going to stop that scale from moving. And now we're ready to locate all of our load cells and chairs and everything in the scale.